Hello guys, hope you all are doing well. Now in the previous videos we have already studied what a transaction is, then the different properties of transaction and the life cycle of the transaction. Now in this video we'll be starting with what a schedule is and types of schedule. So first we'll have a look at what a schedule is. Okay. So, a schedule is a sequence of operations by a set of concurrent transactions that preserves the order of the operations in each of the individual transaction. Okay, so this is the definition of the schedule. Now, what we'll do is we'll first see one example and then the definition will be more clear. Fine. So, first of all, we'll see what transaction exactly includes. Now we already know what a transaction is. A transaction is just a set of instructions, okay, which has been written to perform some specific operations, right? Okay. Now there are two transactions, transaction T1 and T2. Transaction T1 is going to do or execute this instructions, right, which are read A, write A, read B, write B, and T2 have the instructions such as read A, read B, and write C. Okay. Now first of all, what a schedule is? Schedule is going to consider some n transactions. So in this case, that schedule will contain these two transactions T1 and T2. Okay. So just keep in mind the instructions and the sequence of the instructions that are present in T1 and T2. Okay, which we'll be needing in the further explanation. So we'll see what a schedule is now. So there's a schedule. It contains, in our case, it contains two transactions, transaction T1 and transaction T2. Now how the transactions are getting executed? Now schedule is, as we are having schedule for the trains or schedule for the buses, right? So at this particular time this bus is going to arrive, or this particular bus or train is going to departure. It's kind of a same thing over here. This schedule means which instruction of which transaction is getting executed when. Okay, so at this point if you see, in transaction T1, read A is getting executed first, followed by write A, then followed by read B and write B, right? So it is just a timetable, or yeah, the timetable or the sequence in which the instructions are getting executed of the transactions which are running concurrently. Okay, or they are present in the system. They are either they are running concurrently or getting executed serially. That will be seeing later on what exactly they are, right? So over here, what a schedule is, it is kind of a timetable. Okay, so over here it is containing transactions T1 and T2. Now T1 is getting executed entirely first and followed by the execution of T2. Now if you observe, the sequence of the instructions that are present in T1 is same as that we have seen in the previous slide. Similarly, the sequence of the instructions of T2 is the same as we have seen in the previous slide. That is, we have said that this is transaction T1 and this is the set of instruction that it contains, and this is the sequence that is to be followed. Okay, that means, for example, if in C language, if you're writing a program to add two numbers and print the sum of those two numbers, then obviously that program that has been given, right? That is, first you'll be taking the input from the user for one variable, then the other variable, then you'll sum of both the variables, and then you're going to print the answer, right? You cannot do the thing that first you're printing the answer, then you're taking the input from the user. This cannot be done. The sequence of the instruction should be followed, right? Similarly over here, in the case of transactions as well, the sequence of instructions is to be followed. Now what a transaction is nothing but a kind of a program, right? So even though they are running alone in the system, or they are running along with some other transactions in the system, the sequence have to be maintained. As we are maintaining the sequence for the execution of our normal programs, over here as well it goes in the same way, right? So if we see, the sequence haven't changed. So this is the constraint that the schedule imposes, that the sequence of the transaction, the instructions that are present in the transaction shouldn't be changed. Okay, now we'll see one more example. Now see, we are considering same transactions T1 and T2. T1 is going to, if you see this column, T1 is going to perform the same instructions and T2 is also performing the same operations. Only the difference between this slide and the previous slide is their execution timings are changing. Right. First over here what is happening? Only one instruction of T1 transaction is getting executed. Then context switch is happening. Then this instruction, read instruction of T2 transaction is getting executed. Then again context switch is happening. Rest of the instructions that are present in T1 are getting executed, context switch, and then the rest of the instructions of the T2. But individually if I see T1 row, T1 column, the sequence of the instructions haven't changed that was present in the original transaction. Over here if I see this column, the sequence of instructions haven't changed for T2 as well. Okay, so schedule, what is the schedule? It contains n number of instructions and the constraint is that the sequence of those the sequence of the instructions that are present in those transactions shouldn't be changed. Okay, now here is one more example. Here we are seeing two schedules, S1 and S2. Now it is containing the same transactions T1 and T2 as we have seen earlier, right? Now this S1 schedule is containing two transactions and it is also following the constraint that the sequence of the instructions haven't changed. Now the only difference between this slide and the previous one is we are having something called as a commit statement at the end of this transaction. Now what does commit means? Actually we have already seen this concept in our previous videos, but let's revise quickly. So what a commit is going to write all the changes from the buffer in the main memory to the database, right? That means the final updates are been done. All the changes that transaction T1 is doing, all those are written back to the database with the help of this commit statement. Once the commit statement has executed, then the changes are in the database forever, right? They are going to be there even if there is some failure after this commit. Then also the changes that are made by T1 will be present in the database. Okay, and here as well, T2 after completing its normal execution, it is going to execute this commit statement. That is, the changes made by this T2 transactions have been reflected in the database. So when a schedule contains a transactions which either contain commit or abort statement at the end are called as the complete schedule, right? So here is another example, schedule S2, same transactions T1 and T2, but in this case T1 is getting executed successfully along with the commit statement, whereas T2 is going to get aborted because of some failure, I guess, right? So when the transactions are having commit or abort statement at the end in a schedule, then we say that it's a complete schedule. Okay, now we'll move on to what are types of schedules. Okay, so the first type is serial schedule, the next is non-serial schedule. Now first we'll have a look at what a serial schedule is. Alright, so what a serial schedule is? A schedule where the operations of each transactions are executed consecutively without any interleaved operations from other transactions. That means at a time only one transaction is going to get executed. No other transaction is going to get executed when suppose T1 is getting executed, right? So no context switch is going to happen. First, whichever transaction start will get executed completely, then the next transaction will start its execution, it will get executed completely, then the third transaction may start, right? And this may go on. Now how many possible serial schedules are possible? That means if there are suppose n transaction present in a schedule, then how many possible serial schedules are possible? The n factorial serial schedules are possible, right? For example, see here there are two transactions T1 and T2 present in a schedule, right? That means How many possible serial schedules are possible? 2 factorial. That is 2 serial schedules possible. That means what are those? And first T1 will get executed, then T2 will get executed, and the next possible thing is first T2 is going to get executed and then T1 is going to get executed, right? So the different sequences in which the serial schedule is getting executed. So if there are 2 transactions, 2 possible ways are there, 2 possible sequences are present to execute them, right? Now, thus in serial execution, there is no interference between the transaction since only one is executing at a given time. However, there is no guarantee that the results of all the serial executions of a given set of transactions will be identical. Okay, so that means if we execute this schedule in such a way that T2 is getting executed first, then T1 is getting executed. So whatever are the results after this schedule, the results can be different from the results that we get if we execute first T1 and then T2. Okay, so we are not saying that if we are getting different results, then there is some problem in the execution. It is all fine. If we are getting different results, that is all fine. Okay. Anyways, whenever serial schedules are getting executed, they are going to keep the system in the consistent state, keep the database in a consistent state. Okay, but it might happen that if the serial schedules are executed in different sequences, they might give us different results. That doesn't mean that they are wrong. The results are correct. For example, if we see a banking example, it matters whether the interest is calculated on an amount before a large amount has been deposited or after it is deposited. Right? Obviously, we are going to get different results. So if there are 2 transactions, T1 and T2, one is to calculate the interest and other is to deposit amount, right? So if we are going to calculate the interest first, then that interest will be different if we calculate the interest after depositing the amount. Okay, so if the sequence of the transactions changes, then we might get some different result. However, no matter which serial schedule is chosen, serial execution never leaves the database in an inconsistent state. So every serial execution is considered correct, although different results may be produced. Okay, so this was all about serial schedules. Now we'll have a look at non-serial schedule. So what a non-serial schedule is? A schedule where the operations from a set of concurrent transactions are interleaved. That means here the context switch is going to take place. Some of the instructions from suppose T1 will get executed, then some of the instructions of T2 will get executed, and this might go on. Okay, so it is going to be interleaved. That is, some instructions of one transaction, some instructions of other transactions, and so on. Now, if we want to find out that how many possible schedules are possible, then it is actually quite difficult because a large number of combinations will be possible, because over here it contains many possible orders in which system can execute the individual operations of the transactions. So n number of possible orders might be present, right? And the non-serial schedules are not always consistent. They might lead these database into an inconsistent state. Right? So we'll have a look at this example over here. Over here, see, one statement of T1 is getting executed, context switch is happening, and then rest of the operations of T1 are getting executed. So as the context switch is happening, therefore we say that this schedule is a non-serial schedule or a concurrent schedule. Okay, fine. So to sum up this video, what a schedule is? A sequence of the operations by a set of concurrent transactions that preserves the order of the operation in each of the individual transactions. Complete schedule, a schedule that contains either commit or abort statement at the end. Then types of schedule, serial schedule, a schedule where the operation of each transaction are executed consecutively without any interleaved operation from other transactions. The result of all the serial executions of a given set of transactions might not be identical. Serial execution always leaves the database in a consistent state, so every serial execution is considered correct, although different results may be produced. Non-serial schedule, a schedule where the operations from a set of concurrent transactions are interleaved and they are not always consistent. So it's all for this video. Let's meet in the next video soon. Thank you very much. Please leave your feedback in the comment section.